Hello, and welcome to the lesson on pathfinding. Why am I so small? Oh, that's why. For your starter, can you have a quick go at this past exam question? It's asking you about the advantages and disadvantages of a star topology network compared to a bus topology network. Okay, this is the mark scheme. Can you compare your answers to this and see how many marks you reckon you got? One of the topologies we looked at last lesson was a mesh. A mesh topology is where each computer is connected to one or more other computers almost at random. There's no central controller and every mesh will be different. Because of the lack of a central controller, and also because there may be no complete map of how the computers are connected together, deciding how to send a message from one computer to another is a complex task. Let's say Bob wants to watch a movie on Netflix. The movie is streamed from Netflix's server somewhere on the internet, a mesh network. How does the data make its way from Netflix's servers to Bob's PC? There are several routes the data could take, and in reality, the network is much bigger than this. There could be thousands or millions of different possible routes. There are two methods for transferring data across a network with multiple paths: circuit switching and packet switching. In circuit switching, the route is locked until a communication is complete. This means that for a large transmission, other transmissions may be blocked for a long time. In packet switching, the data is split into small chunks called packets, and each one is sent independently. They will likely arrive at different times and take different routes to get there. Because they may arrive out of order, each packet needs to be numbered and then reassembled at the other side. So before we go any further, can we just make a quick note on that? Circuit switching is where a path across a network is established, and that path is locked and remains open for the duration of the communication. Packet switching is where the data is split into lots of small chunks called packets, and each one is sent independently, likely along different paths, and then reassembled at the other side. When would we use circuit switching? Well, since the data arrives in the same order it was sent, the receiver can start using the data as soon as the first bit arrives. This means there's minimal delay or lag when using circuit switching, so it's used where real-time communication is needed. There's a downside, obviously. During the transmission, the entire route is locked and can't be used by anything else. Circuit switching is used by phone networks, not internet phones, just normal phones. There's almost no lag, but when the line is locked, if someone else tries to call, they get the engaged tone. So when would we use packet switching? Well, with packet switching, the network is not locked down. Since each packet can take a different route, each node is only locked for the time it takes one packet to be sent. After that, it opens up again for other waiting packets. The downside is that packets won't arrive in the same order they were sent, so a delay or lag is needed to be introduced to ensure enough packets have arrived to order them before the data can start being read. Data transmissions use packet switching. This is why voice calls over the internet have a lag, but don't lock the device out from further calls. You've probably noticed if you're doing a voice call over WhatsApp, there's a slight pause between you speaking and them hearing it. You don't get that on a straight voice call because voice calls use circuit switching and WhatsApp uses the data network, which is packet switching. So a quick task. Based on what I've just said, which of the following systems would work best with circuit switching and which would work best with packet switching? Remember, we're trading off the ability to send multiple things at the same time with the importance of not having any delay or lag. Have you decided? Well, this is how I'd do it. Downloading a game, streaming a movie from Netflix, and downloading emails would all be packet switching because the lag doesn't matter. Once you start watching the movie on Netflix, it then streams fine. It doesn't matter that it took 2 seconds between pressing play and the movie playing. Same with downloading emails and downloading a game. Pausing slightly before it starts doesn't matter. However, With a telephone call, it does. We want the person to hear us as soon as we speak. Same with a live feed from cameras to the director of a sporting event. He needs to be able to see the things as quickly as possible to make sure he can respond to changes on the field. So the next set of notes, can you write down the advantages and disadvantages of circuit switching and packet switching? Circuit switching advantages are that data arrives in the order it was sent, it arrives at a consistent speed, and it can start being read as soon as the first bit arrives. The disadvantage is that only one transmission at a time along each channel is possible. The networks get clogged. The advantages of packet switching are that multiple transmissions can happen simultaneously, and large transmissions don't clog the network. The disadvantage is that lag needs to be introduced to allow several packets to arrive before reading, as the first packet sent may not be the first packet received. For both packet switching and circuit switching, a route through the network has to be decided. So how does that happen? In order to choose the best route, each node continually tests its connection and assigns them a cost. A lower cost means a faster connection. Route finding algorithms are used to determine which route through the mesh will have the lowest cost and therefore take least times. There are a range of these algorithms. We don't need to know any of them for this course. A quick question for you. On this network, which route from node A to node D has the lowest cost? For example, node A to C to D has a cost of 11. Last set of notes. Can you draw out a mesh network and can you add the costs on each connection? And then note that a cost is assigned to each connection in a mesh, and route finding algorithms are used to find the lowest cost route between two nodes. So for the assess task for this lesson, I'd like you to take all the information we've learned from networks so far, that's LAN, WAN, the advantages and disadvantages, the topologies, bus, ring, star and mesh, and then circuit switching, packet switching and pathfinding, and arrange them into a mind map. The mind map can be hand-drawn or created using an online tool, but either way it needs either scanning or photographing and uploading to the VLE.